what is the standard deviation of number of recoveries among 48 patients when the probability of recovering is 0.75. Here n is equal to 48, p is given to us 0.75, this is probability of recovery, so q will be 1 minus p is equal to 0.25. Now, in binomial distribution, the standard deviation is under root npq. This is the standard deviation. Let's fill the number here. So it is under root 48 into 0.75 into 0.25. So this is nothing but under root 9. So our answer is 3. So answer is B. X is a binomial variable with n is equal to 20. What is the mean of x if it is known that x is symmetric? Now remember, when the binomial distribution is symmetric, the probability of success p is 1 by 2 and the probability of failure is also 1 by 2. So, mean for the binomial distribution is n into p. Here n is given 20, p is 1 by 2, so the mean will be 10. So our answer is B, 10. If x is following binomial distribution with parameter n and p, what would be the greatest value of the variance of x when n is equal to 16? Now, we'll get the greatest value of variance when the distribution is symmetric. And in binomial distribution, when the distribution is symmetric, p is 1 by 2 and q is also 1 by 2. So, let's find out the variance. The formula to find out the variance is npq, and that is 16 into 1 by 2 into 1 by 2. So the highest variance is 4. So our answer here is B, 4. If x is a binomial variate with parameter 15 and 1 by 3, what is the value of mode of the distribution? See, binomial distribution has two parameters. One is n and another one is p. Here, n is given 15 to us and p is given 1 by 3 to us. Now if p is 1 by 3 and n is 15, then we can apply the formula to find out mode. Mode of binomial distribution is equal to n plus 1 into p. So it is 15 plus 1 into 1 by 3. So this is 16 divided by 3. Now 16 divided by 3 is nothing but 5.333. And since the binomial distribution is a discrete distribution, this discrete distribution will ignore this point and our answer will be 5. So in this case our answer is B, 5. What is the number of trials of a binomial distribution having mean and standard deviation as 3 and 1.5 respectively? Mean of a binomial distribution is np, which is given to us 3, and the standard deviation is under root npq, which is given to us 1.5. So if the standard deviation is 1.5, then the naturally variance npq will be 2.25. Now, np is equal to 3 and npq is equal to 2.25. What we can do is, we can just fill up, or we can just replace this np by this np by the number 3 here. So it is 3Q is equal to 2.25. Here it is 2.25. So Q is equal to 2.25 divided by 3. So Q is nothing but 0.75. Now if Q is 0.75, then P will be 0.25. Just fill this number into the formula of mean. So N into 0.25 is equal to 3. So naturally N is going to be 3 divided by 0.25, which is nothing but 12. So our answer is B. What is the probability of getting 3 heads if 6 unbiased coins are tossed simultaneously? Now here N is equal to 6 and X, required number of success, is 3. Now the probability mass function in binomial distribution P of X is equal to NCX into P raised to X and into Q raised to N minus X. Let's put all the number here. N is 6C3 into P of X. Now P is 0.5 here because it is a problem involving tossing of a coin, and in coin head has a probability of 0.5 and even tails has a probability of 0.5. So Q is also 0.5. 0.5 raised to, I should put here 3, and here also 6 minus 3 is equal to 3. Now let's solve it by using this calculator only. The value of 6C3 is nothing but say 6 into 5 into 4 divided by 3 into 2 into 1. So it is 3 to the 6 would cut. So the value is 20. And into 0.50 raised to, I can say actually it is 6. This 3 plus this 6 minus 3 is 3. 3 plus 3 is 6. Let's solve it by calculator only. 0.5 into, I can press equal to button 5 times. 1, 2, 3, 4 and 5. So this is 0.015625, which is nothing but 0.5 raised to 6, and I should multiply it by 20. 5 into 4 into 20 is equal to 0.3125. So our answer in this case is 0.3125. If the overall percentage of success in an exam is 60, what is the probability that out of a group of 4 students, at least one has passed? At least one. This sum can be done in 2 ways. P1 plus P2 plus P3 and plus P4. This is our required probability. At least one. So it can be 1 or more than. And the second way is just find out P0 and deduct it from 1, and we'll get the probability of 1 or more than 1. So I am going to use this way here because it will be very easy. Let's find out P0 here, which is NCX. So 4C0 into P is 60%. So it is 0.60 raised to 0, and the Q is 0.40 raised to 4. Let's 4C0 is 1 into 0.60 raised to 0 is also 1. 0.4 raised to 4. Let's solve it by calculator. 0.4 into 1, 2 and 3 times equal to, it is 0.0256. So we should write here 0.0256. So our answer of P0 is 0.0256. But now let's deduct it from 1. 1 minus 0.0256. So our answer here is B, 0.9744. What is the probability of making 3 correct guesses in 5 true and false answer type questions? Now true and false. So the probability of the answer being true is 1 by 2 and the probability of answer being not true is also 1 by 2. Now out of 5 tries we need 3 correct guesses. So our n is going to be 5 here and x is going to be required number of successes, which is 3. The probability mass function for binomial distribution is ncx into p raised to x into q raised to n minus x. So ncx is 5c3 into p raised to x is 1 by 2 raised to 3 and q raised to n minus x is 1 by 2 raised to 5 minus 3 is equal to 2. The value of 5c3 is 10, 1 by 2 raised to 3 is 1 by 8 and 1 by 2 raised to 2 is 1 by 4. So it is 10 divided by 32. 10 divided by 32 is 10 divided by 32 is nothing but 0.3125. So our answer is 0.3125. So in this case the answer is A, 0.3125. If the standard deviation of a Poisson variate is x is 2, what is P? 1.5 is less than x is less than 2.9. Poisson distribution is a discrete distribution to find out number of success. Now number of success cannot be a fractional figure, so in this problem we should find out the probability of a round integer between 1.5 and 2.9 and which is 2 only. So we will find out P2 here. Now in Poisson distribution the probability mass function P of x is equal to e raised to minus m into m raised to x divided by x factorial, where m is equal to average. M is equal to average. Standard deviation for the Poisson distribution is under root m. We have already been given the standard deviation which is 2. So 2 is equal to under root m. Take square on both the sides, so m will become 4. Now just fill the figure into the formula. P of 2 is equal to e raised to minus 4 raised to 2 divided by 2 factorial. Now you might be wondering why or how I should compute the value of e raised to minus 4. So this can be easily done by using calculator. Let's use it. E is 2.7183. Now press into and press 3 times equal to 1, 2 and 3. So this is the value of e raised to plus 4. And since I want to find out e raised to minus 4, we need to find out the reciprocal of it. Just press the button of reciprocal, and in your ordinary calculator you can press the button divide and then equal to. So the value of e raised to minus 4 is 0.01831. You multiply it by 4 square is 16 and you divide your answer by 2 factorial is 2. So our final answer is 0.1465. Now in our solution 0.15 is given, so we can make the figure nearer to 2 digit, so it is 0.15. So our answer is 0.15 in this case. If the mean of a Poisson variable x is 1, what is P? X is equal to takes the value at least 1. Now at least 1 means we should start from 1 and we keep on adding all the values, so this will always run up to infinity. How will we count it out? We can do it by another way, a reverse way. We can just minus P0 from 1 to get our required probability. The both expression is actually same. Either you find out this or you find out this. Let's first find out P0 here. P0 is equal to e raised to, m is given to us 1, e raised to minus 1, 1 raised to 0 divided by 0 factorial. So it is nothing but e raised to minus 1. The value of e raised to minus 1 is 2.7183. Just divide equal to or reciprocal of it. It is 0.3692. I made a mistake. It is 2.7, not 2.7083. Let me do it again. 2.7183 divide equal to reciprocal 0.3678. So value is 0.3678. Let me just deduct it from 1. 1 minus 0.3678 is nothing but roughly 0.632. So our answer is C here. If X is following Poisson distribution with parameter m and its coefficient of variation is 50, what is the probability that X would assume only non-zero values? So here the coefficient of variation is 50, which is CV, and the formula of CV is S upon X bar into 100. So in our case, we can write 50 is equal to S. S in case of Poisson distribution is under root m, and X bar in case of Poisson distribution is m into 100. So we can say 1 divided by under root m is equal to 0.5. So under root m is equal to 2. Take square on both the sides, then m will be 4. So this is the value of m. Now X would assume only non-zero values. So we have to do 1 minus P0. The value of P0 is nothing but e raised to minus 4, because the value of m is 4, into 4 raised to 0 and divided by 0 factorial. We can solve it by calculator. So 1 minus e raised to minus 0.4 will be solved like this. E is to 0.7183. Press into and equal to button 3 times, 1, 2 and 3. So 54.59 is e raised to minus 4. Press the button of reciprocal, or you can press divide equal to. So this is the value of e raised to minus 4, 0.0183. Let me put 0.0183, and if we deduct 1 from it, then our answer is 0.9816, but we will ignore the sign minus here. So in this case our answer is 0.982. B is our answer. If 1.5% of items produced by a manufacturing unit are known to be defective, what is the probability that a sample of 200 items would contain no defective item? So here M average is 1.5%. So it is given in proportion. So in our case, M will be 200 into 1.5% is equal to 3. Now 200 item would contain no defective item is our question here. So we need to find out P0. So P0 is e raised to minus 3 into 3 raised to 0 divided by 0 factorial. So value of e raised to minus 3 is 2.7183 into 2 times equal to, and then the reciprocal button or divide equal to button. So the value is 0.0497. So our answer in this case is A, 0.05.